Hi, today we will see extrusion. Extrusion from manufacturing technology. Extrusion is the process in which the metal caused to flow through the restrictor orifice, so creating an extremely elongated strip in uniform, but comparatively small cross section. The operation is identical to squeeze both paste out of the toothpaste tube. It is also similar to code drawing, except the material is pushed, not pulled through the hole in a die, and the operations is often carried out at high temperature. An important feature of the extrusion process in general is that the grain flow of material lies in the direction most suited for the resist imposed stresses in surfaces. Metals that can be extruded include aluminum and its alloys, copper and its alloys, lead and its alloys, magnesium and its alloys, and tin and zinc and the alloys of the few exceptions. By the extrusion process, it is possible to make the components which have the constant cross sections over any length can be and by rolling process. Some extrusions or complexity of parts can be obtained by the extrusions is more than that of the rolling, because the die required being very simple and easy to make. Also extrusions single pass and process unlike rolling. The amount of reduction that is possible in extrusion is large. Generally, brittle materials can also be very easily produced. Large diameter, thin walled tubular products with excellent eccentricity tolerance characteristics can be produced. The extrusion pressure for a given material depends on the extrusion temperature. The reduction in area in extrusion speed. The extrusion speed depends on the work materials. Too high an extrusion speed would cause the excessive heat generation in the extended metal casings of the lateral cracks. Extrusion ratio. It is defined as the cross-sectional area of billet of cross-sectional area of the products. Its value for hot extrusion for steel is about 40 is to 1. Aluminum is 40 is to 400 is to 1. Advantages. The shapes can be extruded. Those, if produced by other methods, shall entail the more cost of the comparatively. The thinner walls can be obtained by increasing the forming pressure. Due to the high reduction ratio, the excellent transverse flow lines, consequently the part has an added strength and the secondary operations are made easier. The extrusion dies are less expensive comparatively, and so and moderately short runs are practical. Extrusion process allow the low most in process of redesign. The dimension tolerances of extrusions are very good. There is more flexibility in design for adjacent thin and heavy sections, or as well as for difficult re-entrant angles. Sharp corners is not practicable in the other process can be readily be obtained by the extrusions. It is also possible to get the sheaves with internal cavities in extrusions by the use of the spider dies. Extrude sheaves can be replaced the billet and members previously machined from the bar stock. Extrusion is an ideal process for obtaining the rods from the metal having the poor ductility limitations as compared to roll forming. Extruding speed is slow. Though the accuracy is good and entirely adequate for the most application, yet it is not close as machine part would be. The size of dies poses that can be economically built for limiting factor. Cost of extrusions are generally greater as compared to the other techniques. In productivity, the extrusion is much inferior of the interior to rolling, particularly to continuous the varieties of the process. Waste is higher in extrusion than in rolling. High rolling cost. Applications. The manufacture of parts of high dimensional accuracy, the manufacture of sections and pipes of complex configurations, the medium of the small batch productions. Medium and small batch productions are working of poorly plastic and non-ferrous metals and alloys. The extrusion process are classified art extrusions, forward extrusion and backward extrusions, forward extrusion and hydrostatic extrusion, backward extrusion, impact extrusions, cold extrusions and forgings. Art extrusion process, forward or direct extrusion process. In this process, a billet of metal worked in the suitable shape of the material to be extruded is placed in container. At the end of the container is fixed on the die while the other metal is forced to flow through the die and hydraulically driven the ram of the follower pad. Much work must be supplied to overcome the resistance and high frictional forces between the billets and wall of the container. The problem of friction particularly severe in the case of the steels and because of the higher extrusion temperatures. To reduce the frictions, lubricants are to be used. At lower temperature, the mixture of the oil, graphite is generally used. The molten glass is generally used for extrusion steels. To reduce the damage of the equipment, the extrusion is finished quickly. The cylinder is cooled before further extrusions. Backward or indirect extrusions. The ram which houses the die is hollow plunger ram. It is termed as a backward or indirect. The opposite direction of the flow of metal to that the ram movement. Thus, billet in the container remains stationary and ends no frictions. Also, the extrusion pressure is not affected by the length of the billet in the extrusion press since the frictions is not involved. The surface quality achieved in generally good since there is no heat cracking due to the frictions between the billet and the extrusion of the cylinder interface. The disadvantages of the back extrusion is that the surface defects and billet would end up the final product unlike the direct forward extrusions. The use of the backward extrusion is restricted due to the fact that the ram must be hollow and that extrusion of the product must be passed back through the ram. The process of direct extrusion is generally mechanically more convenient. The forward extrusion, it is the simple and the bit is limited fact that the as the ram moves and the billet must be slide to shear at the interface between the container. The high friction of the forces is involved. High extrusion of the forces is required. However, chemically more convenient. The scrap or the process of waste is about the 80 to 20% of the billet weight. The billet proper do not move a relative container instead of die moves. The low friction process, low friction forces, the frictions involved is only between the die and the container and this independent of billet length. Extruding force 25 to 30% is less than the forward extrusions. However, a long hollow ram is required. This limits of supplied is due to this complex of the design tools and extrusions finds limited applications. Scrap or the process of waste is only 5 to 6% of the billet weight. Advantages of the hot extrusions, very rapid process involves the low tool cost, owing the high pressure used and a compressive nature of process of very dense structure of the metal is obtained. In several cases, it proves cheaper than the die castings comparable finish of the tolerance. It is the ideal process for producing parts of uniform cross-section on large quantities. Cold extrusion process, hooker extrusion. The extrusion is down method, a cup of the first formed by suitable working operations. The extrusions then consist of elongating, thinning of walls of cup using the shoulders. For cold working process is commercially applied mainly the production of small wall copper, aluminum, seamless and cottage. The hydrostatic extrusion. The extrusion is the method is required is applied through the fluid medium surrounding the billet. Although the presence of the fluid inside the extrusion chamber eliminates the container wall frictions, the process of the finds limited industrial application because of need of for specialized equipment and tooling and low production rate. It is usually carried out at room temperature. The pressure transmitting fluid commonly used for hydrostatic extrusion or the geyser and SE30 mineral and lubricating oil. Because of hydrostatic pressure increases the ductility of the material. Brittle materials can be extruded successfully by this method. The glanding metals making the wires or less ductile material. Extrusion of clear nuclear reaction of the fuel rods. Impact extrusions. This process is quite similar to the Hooker process, but flow of metal is in opposite directions. The punches of descends at high speed and strikes the balance, extruding it upward. The thickness of extruded tubular section is the function of clearance between the punch and die cavity. The process is applied primarily to lead the aluminum, manganese, tin, zinc and their alloys. Cold extrusions. It is similar to that impact of the extrusions. The main difference of the side walls are much thicker and their height is smaller. The punch is slowly descends over the slag or kept on the die. The forging of the some metal between the punch and die The rest of being extruded is clearance between the punch and die. இது சார்ஜ் பண்ணுமா சார்ஜ் punch and die, and the side walls are generated on the short thick with any in end and profile, unlike the impact extensions and the afterwards the component is rejected by means of ejector put provided in the die. The backward cool extrusion process are different from other extrusion process in that each stroke of punch proposes a directly usable single component which may not be necessarily have to uniform cross sections over its entire length. Also, these are limited to smaller size and the non-ferrous alloy only. The advantages of cooled extrusions. The cooled extrusions is gained wide acceptance in industries because the following advantages over the hot extrusions: improve the surface finish provided lubrication is effective, high production rates, relatively low cost, lack of oxide layers, good control dimensional tolerance, thus requiring a minimum machining operations, improve the mechanical properties resulting from the strain hardening provided that the heat generator plastic formation and friction does not recyclist and extruded metal. In cold extrusion, stresses on cooling are very high, especially with steel workpieces. The design of cooling and selection appropriate tool material, therefore, crucial success in the cold extrusion. Punches are critical component. They must have the sufficient strength, toughness, resistance, wear and fatigue. Lubrication also crucial, especially with steel, because of generation of new surfaces. This possibility of seizure between the metal and tooling caused by the breakdown lubrication. The temperature rises in cold extrusion is an important factor, especially at high extrusion ratios. The temperatures may be sufficiently high to initiate the complete recrystallization process and cooled worked metal, thus reducing the advantages of cold working extrusion force. In the extrusion process, the main variables are strength of the billet material, size of the billet, extrusion ratio, die angle, coefficient of friction, speed of the extrusions, and temperature. Extrusion equipment. The process of extrusion process may be either hydraulically or mechanical or according to the pressure required, and either in the vertical or horizontal. Hydraulic press is the more usually vertical since it has great flexibility and compactness and less reliable to injury to resulting from the improper use. The mechanical vertical extrusion press, given the high output and each of these piece is spent only the second or two actual and the contact with the dies. This short and of contact means the little heat is lost as a result of radiations and conditions, so that if require the little and extended the part can be extruded and can be referred to street reducing mill. The dies employed are often high speed steel and or always high quality special alloys tool alloys tool till the punches may be also high quality steels. The lubrication is plentifully employed in most instances. Extrusion defects, extrusion defect, surface cracking, internal cracking, and the common defect of extrusion is known as the extrusion defect. The pipe, tall pipe, fish failing excess arises from the back of the flow of material pushing at the end of the face of the bullet pump into the core of the product. Such defect means the weakness of the product since the surface of the layer is normally contained by the outsides. These defects can be reduced by modifying the flow pattern, the less homogeneous one, as by controlling the frictions, minimizing the temperature gradients, by machining the surface of billet period extrusions to limit the scales and impurities, by using the dummy block, the smaller diameter that can be container, thus leaving thin the shell container wall as the extrusion progresses. Surface cracking, sometimes heat is generated due to the extrusions may raise the temperature of the job, resulting the development of surface cracks. These cracks are irregular and are usually the result of shortness. They occur especially with aluminum, magnesium, and zinc alloys are also absorbed in the other material, molybdenum alloys. The surface cracks can be avoided by using the low temperature and speed. Surface cracking may be allows to allow the temperature and has been attributed to periodic sinking and the extruded the product along the die land extrusions. Internal cracking, the center of an extruded product can be developed the crack variously known as a center burst of the center cracking arrowhead fractures. These cracks are attributed to state the hydrostatic tensile stress, the deformation done of the die, the tendency of center cracking, increasing the die angles level, impurities, and decreases the increasing extrusions. The design considerations. High velocity of forging. The high velocity of the forging is known as the high energy forming, the pneumatic of the mechanical velocity forging. The high velocity forging machines provide the very high impact, very low operating cost. The machines are based on the essential of the same principles as of the drop hammer impact forging machines. The provide of the greater agencies given the ramp weight by using the velocity of order 2 to 10 times of those hammers. These are based upon the following methods of releasing the energy of chemicals, high explosives, propellants, gas mixtures, electrical, and exploiting the wires, spark discharge, magnetic field. These machines can be effectively used for forging the extruding, compacting, in many other metal forging operations. The most effectively performed operations, however, is closed die forging metals. Even the ceramics can be worked on the machines A wide variety of the material can be formed for forged, including the extrudates, the refractory of material, stainless steel, non-ferrous alloys, high-strength materials. Some of these are not usually of the forgeable. The complex parts can be made in one blow. The draft allowances are reduced and some of the cases are eliminated. Scaling and decarbonizations of metal surface during the operations are almost eliminated. Extrusion of even such materials with each either cannot be extruded. The conventional machines or will need the conventional machines giant of the sizes of purposes is also possible on these machines. Tolerance and surface finish are improved over the obtained the conventional forging techniques because of the strength of the fatigue resistance are improved. Parts can be made similar. Repeatability is excellent. Overall production cost is low. Limitation parts configurations usually limited one piece of dies. If two dies or split dies are necessary, the economic of process of become the debatable. There is a limitation of size or weight of the product. These machines can be handled extremely large, very heavy forgings. The produce on these machines applications. Few examples of the type of the products made on these machines are wall bodies, gears, engine housings, rocket components, missile components, the orbital forgings, the code forming process. In this process, the pressure of the upper die of the workpiece is concentrated on a small area at any time and not for the total workpiece of area of the conventional forgings. The upper die is slightly inclined to the vertical axis of machine and it imparts the high frequency of the circular rocking motion across the top surface of the workpiece. At the same time, the workpiece is slowly moved hydraulically upward and pressed against the orbiting upper die. The forging operation is completed. The hydraulically ram touches the present stop and the ram is then lowered and hydraulically operated. The ejects the forging the lower die. The advantages low equipment cost and the press capacity requirements are only 5 to 10% of that needed for conventional forging. Better surface finish. Limitations of this process is that the forging is obtained filling the lower die and so the bottom surface of the upper die should be flat and smooth. Examples of the parts produced by this process: the parts are flanched with intended crown shapes and discs. Incremental forging. In this forging method, very big forgings are made by working of different areas of the forging into the shape one at a time, as only limited the area is worked at any time of the forging. Equipment can be much smaller in the capacity as the compared of the conventional forgings. This makes it is possible to forge the huge parts of the presses and modest capacity limitations. The working workpiece tends to cool below the forging temperatures as it moves from the incremental step to step, reheating the part and its original forging temperature may be destroy the thermomechanical work already done. This is on its case of many alloys. It may be prevented by reheating the workpiece progressively to lower temperature after its temperature falls below the forging temperature by covering the billet using the insulting the blankets and other coatings so as to reduce the heat loss. The liquid metal forging process, also called as the skew casing, hybrid between the conventional casing and the forging methods, and produces the complex shaped from the molten metal in a single step. In this process of forging, the molten metal is poured into the bottom forging die and allowed solidify and partially. Then the upper bottom dies are closed and pressure and applied the maintained until the solidification is completed. The dies are open and closed. The forging component is ejected from the bottom die. The advantages: this forging process claim the following advantages over the conventional casting and forging process. Low capacity of the presses are required. Economical from the material point of view, the yield is higher in compressions and to sand castings since the gates and races are not needed. The tooling and equipment needed are basically simple. The lowest readily available, no gas and shrinkage is porosities. Thinner and more complex components can be produced. The cast as well as wrought alloys can be used. The mechanical properties of the products are compatible of the conventional forging's limitation. The process cannot be employed to produce all other component shapes. Liquid forged parts necessitate the different heat treatments. The gatorizing. The gatorizing is a precondition in the inert atmosphere to obtain the temporary conditions to fine-grained microstructures, resulting low strength, high ductility, working of the workpiece at temperature slightly below the recrystallization temperature. After preconditioning, the isothermal process of forging operation is carried out slightly below the recrystallization temperatures. Finally, the heat treatment operations are done on the forgings to get the normal eye strength and hardness. The forging method is employed for making the argonite component, nickel and titanium based alloys. Defects in forgings. Although the forging process generally gives a superior quality of the products compared to the other manufacturing process, there are some defects that are likely to come if proper care is not taken. In forging process designs have brief descriptions of such defects is given. Cold shed. This is usually occurs at the corners at the right angles to the surface. This is caused mainly by improper design of the die, wherein corners and fillet rails are small, as a result which metal does not flow properly into the corner and ends up as cold shed. Unfilled sections. It is similar to the incident in castings and occurs when the metal does not completely fill the die cavity. It is usually caused by the insufficient metal or insufficient heating of metal flakes. Basically, these are internal ruptures. These are caused by improper cooling of rods forging and can be remedied the following proper cooling practice. Scale pits. These are the irregular depression of the surface of forgings. These are primarily caused because improper cleaning of stock is used for forging. Improper grain flow. This is caused by the improper design of die, which makes the flow of metal not flowing the final intended directions. Internal cracks. This can be results of the too drastic change in shape of the raw stock of too fast rate die shift and the defect of the misalignment of the two die odds. Burnt overheated metal. This defect proper heating conditions of the metal is too long. The cleaning and finishing and of forgings, removal of oxide steel due to the contact of heated steel with air thin layer is formed on the surface of the steel forging. The amount of the steel depends upon the forging temperatures and length of the time of the operations. The steel can be removed by employing the stem compressed air cleaning by pickling. The odd steel from the surface of forgings can be removed by pickling process. Pickling process consists of immersing the forging in a tank filled with acid solutions 12 to 15% of concentrate H2SO4 water. Doubling process. This process is employed for removing the scales and general cleaning of forgings. This process is only for long and with some abrasive materials such as the as coarse and sand. The small metallic particles are placed in the barrel titled and barrel is rotated the low speeds. The action is loosened so the surface of forging and results in general cleaning on forgings. Blast cleaning. The process consists of directing the jet of sand and grit metallic shards against the forging. By this process, the scale is removed by smooth surface and is imparted to the forgings. The heat treatment forgings. The forged parts are generally heat treated for the following reasons: to relieve the internal stresses set up during the working and cooling, to normalize the internal structures of the material, to improve the machinability, to improve the hardness and strength, and the other mechanical properties. The common heat treatment is given. Forged components are annealing, normalizing, and tempering. Design consideration. The parting line of the forging is as far as possible should lie in the one plane. The forged component should be ultimately be able to achieve the radial flow of grains or fibers. In order to facilitate easy removal of forging dies and sufficient draft on the surfaces should be provided. Generally, a 1 degree to 5 degree draft is provided on the press forgings, 3 to 10 degree on the drop forgings. As far as possible, the sharp corners should be always avoided to prevent concentrations of stresses leading to fatigue of the failures and facilitate the easy in forgings. In order to facilitate easy flow of metal, two thin sections should be avoided. The presence of packets and recesses in forging should be avoided while deciding the forging and finishing temperatures. Metal sinkages and forging methods should be duly taken into the account. Adequate allowances of the component of metal shrinkage, machining, die, wear, trimming, and mismatch the die should be provided. Wire drawing. The wire drawing is a process of reducing the diameter of the metal rod by drawing them through the conical opening in die blocks. Wire drawing is fundamentally a slip of the process. The steel and the iron non-ferrous rod is converted into the wire drawing through the conical hole having the included angle 8 to 24 degrees. In continuous wire drawing, the wire passes through the succession of the hole of decreasing the size in the dies made of steel, tungsten carbide, and ruby diamond. Reduction in cross-sectional area is easily being above the 30%. The rod used for the wire drawing are first pickled in acid to remove any scale and then electrically but welded, and at the end of the rod is tapped sufficiently to fit the dies by passing it through the pointing the machines, which generally takes the form of the two motor driven rollers, having the number of the grooves of decreasing size between the which the rod is rolled. The rod may be coated with iron hydroxide and copper or tin applied during the after picking. The rod is then fed into the wire drawing machines, which may be fitted with 6 or more drives through which the fire is drawn by means of the number of the power driven pulleys or rotating drums. Although the principles of is similar in each case, the machines of the differ in designs and the practical purposes is broadly divided into non-slip and slip types due to the great heat generated by the friction of the wire in dies. Both the dies drums are continuously cooled by circulating water through them. Lubrication often ensued by passing the rod through the dry soap on its way up to die. On some designs, however, the synthetic lubricant is poured under the pressure into the dies, each which is this continuously lubricated over the whole of its surface. The separate cooling equipment is provided for the lubricant. A different method of overcoming the cooling and lubrication problems is to employ a wire drawing machines operating the slip principles. Modern alloy steels dies have the long life of the minimum efficiency tungsten carbon dies, replacing the steel. The ruby and diamond dies are also employed for belts, their use only being confirmed mm, trimmed and then drilled for the drilled, drilled or filled in the diamond powder and oscillated for the several hours. When the hole has been closed, finished 0.0025 mm, the die is then mounted on the metal holder. When very fine wires are produced, the composite wires is employed drawing platinum. For instance, may thousand times of the finer than the human hair has been drawn by casing of platinum, silver, and increasing the overall diameter. Mechanics of the wire drawing, the cross-section of the area, the drawing machines can be arranged in order. The wire drawing is mechanical properties because for the cold working, the material loses the ductability during the wire drawing process, and when it is repeatedly drawn to bring the final size, the intermediate annealing is required to restore the ductability. The drawing machines can be arranged for the tandem so that the wire from the one die is coiled up to the sufficient length before the re-entered into the subsequent, and so on. The coiling of sufficient wire helps for any dependency of the speed wire drawing in any die, since there is no change in volume of successive drawing have done for the higher speeds. Defects in drawing is similar to those observed in extrusions, especially the center cracking. The tendency of cracking increases the increasing the die angle with increased reduction of pass with frictions with presence or inclusion of material. Another type of the defects formation is seems to the longitudinal scratches on folds of materials. Such defects can be opened up during the subsequent form of the operations: offsetting, heading, thread rolling, bending, and rod of wire. The tube drawing. The tube drawing is one of the method of drawing the tubes. Method of most commonly used. The method of floating metal corrections of stripped in the contour. The method is usually for the small sized tubing. The mandrel of rod is used for the insect diameter tube walking. The billet gripped between two rolls which spin high speed. Spinning action tends to open a hole or cavity and the axis of billet. The plug metal mandrel bar is pierced through the center and round table is easily produced. Rotary piercing is important method of rough pierced blank being finished by plug rolling over the mandrel between the air grooved rolls. For making the tubes, large diameter blanks are initially rough pierced and then giving the second larger piercing before being finally rolled. Metal stamping and forming. Stamping is a general term of the number of operations such as punching, blanking, sharing, bending, and forming that are performed on the press with the use of the dies. Stamping dies consist of punches usually held in the upper half of the die and matching the dies which are normally located in the lower half. Press working may be defined as the chipless manufacturing process but by which various components are made from the sheet metal. This process is weight fabricated or is small items divide diverse size shape both simple and complex such washers, bushings, retainers, ball bearings, etc. The parts made on the cold sheet of the metal working the narrow tolerance of the ice surface finish. Subsequent finishings and are delivered to the assembly of the shop. Productivity of labor is quite high. Cold press working. Initial material is low carbon steel, ductile alloy steels, copper alloy steels, aluminum and its alloys, 6 to 8 mm thick die sets. Punches are set. The punch holder and dies the two together or dies called die sets. The die set of the guide pins keep the upper half of the in alignment with specificities of the die changing when changing from the one part to the another then the bending is the operations of deforming flat sheets along the straight axis, natural plane and lies. It is a very common forming of the process and changing the plate into the channel, drums and tanks. The V-bending, the wedge-shaped punch press forces the metal sheet and strip. The V-dies are the ones that are most commonly used. The wiper bending is 90-degree bends only. Here the work is held firmly to the die. The punch bends extend the portions of the blank. The process of specifically designed of these operations are called press digs. Bending load may be calculated from the knowledge of material properties and die characteristics. The spring back at the end of the bending operations when the pressure of the metal is released. There is an elastic recovery by the material. This causes decrease in bend angle and this phenomena is termed as the spring back. It is the extent to which the metal tends to return to the original state or positions, undergoing the bending, forming operations, stretch forming and overbending, bottoming, ironing, deep forming in sheet metal, the flat metal hollow shapes by means of the punch to follow the die cavity if the depth is one or more times the diameter. The process is called deep forming. Forming of shallow shapes is sometimes referred as sampling, but distribution is not clear since the sampling is not used to describe the cutting the flat figures or the patterns in the deep drawings, also called as the radial drawing. The parallel walled cup is created from the flat blank. The blank may be circular, rectangular, or more complex outline. The blank is drawn into the die cavity by action of the punch. Deformation is restricted to the flange and draw the radius. No deformations occurs under the bottom of the punch. The punch forms the cup above the materials in the flange decreases. There should be the no appreciable change in thickness of the material between the blank and finished part. When it is desired to reduce the metal thickness, it may be done in the secondary operation as in ironing. The important variable of drawing are the frictions, the squeezing force, permeability of the material. The following materials being used for the deep drawing operation: soft scale and the copper, brass, aluminum and their alloys, magnesium and their alloys, zinc and variety of the non-ferrous alloys. Some common products of deep drawings are automobile bodies, lamp reflectors, cylinders and various small components required in the automobile industries. The metals and alloys are suitable for the deep drawing should be special of the deep drawing quality and should be tested so that the required property of uniform specification is specified. The variations in grain size and presence of harmful impurities will be import the bad finish to the finished of articles. In the case of the materials work hardened, the stress relieving anneal may be necessary for during one or the more intermediate stages. Stretch forming in this method producing the contours of sheet metal, thinning and straight hardening are inherent in the process. Then the jaws are and form the blocks of hydraulically actuated to provide the control pressure adjustment to meet the varying conditions. Characteristics of the material is formed. The stress forming consists of the first stretching. The metal is behind its yield point while it is straightened, wrapping it around the form of the block. It is particularly suited for the long sweep bends and extruded shapes. The main advantages of type of forming that only dies are needed. The thickness reduction should not be exceed 5% of the original thickness. The stretch forming process, the spring back is completely eliminated because of forming is done introducing the uniform tensile stresses in fine increments, the sufficient magnitude to exceed the elastic limit of metal, thus causing the material to take the permanent shape. The process is applicable to a wider range of the material because of the ductility is least of the important factor in stretch forming. The desirable qualities in metal for maximum stretchability or toughness and fine grain structures and a large spread between the tensile yield ultimate strength. It has been found that annealed material which has high strain hardening rate best suited for the stress forming metal spinning. It is the one of the oldest method for producing the wide range of the goods which have an axis of rotations for small batch productions. The spinning, because of simplicity of equipment needed, the easy with which the chuck can be prepared, often gives a lower overall production cost than any alternative. So the process is lends itself to production of goods and direct from the flat blank. It is also very useful adjacent to the press and drop the stamp. In later, the direction is used to finish articles and could not be readily be handled by any other means. Hence, the spinning lathe is often used along the with the press and drop of the stamp, trim the bed and burnish the stroke over the neck down. The hand spinning and machine spinning. The hand spinning revolves with high speed, is subjected by a steel or the pressure is exerted to the operator, is prevented by from slipping by means of the peg. The leverage is obtained are just suitable for the classwork being handled, and the skill is to use for the experience of handling the various classes of material essential. If the metal is worked fully by in one place, it becomes hardened, and the result may be the cracking, buckling, even tearing of metal. The art in metal spinning lies in working the metal tool over the whole surface on coercing the metal towards the desired cross section. As the work may proceed, the surface become work hardened, and it is necessary to resolve the interchange of annealing. Machine spinning. Machine spinning is very similar to the manual spinning, but is always used for the conjunction with press to perform the some operations that cannot be readily done. The latter type of the machines rarely is the machine spinning is used for to draw the blank on the straight down. The method of operating is also different. In place of teeth rest, the hand spinning tool, the compound side is used of the conjunction with roller mounted fork. By constantly adjusting the positions of slides, the roller is made to give the desired contour. For machining the spinning, the chucks are made by the either the casting or suitability hardened. The rollers are best made from the good alloy steel that will take the hot surface. For some jobs, rocking slide is also fitted to the machine and is used with compounders. The permits such operations as tuning, beading, and to be done at the same sitting as say spinning or burnishing or spinning. Or spinning metal is used commercially to dish the thick circular plate, some shape of resolving the form of the block. Or spinning machine is a combination of the vertical press and large vertical spinning wheel which rotates the vertical axis. Power actuator rollers to do forming. The part is rotated. The metal is up to the 150 mm thick is routinely odd spin and dish the pressure vessel and tank sheaves. Odd spinning is also used for the sheave inner plates of odd to form the metals like titanium. The advantages of spinning some complex sheaves or the re-entrant sheaves and kettles and pitches etc. can be produced economically. The equipment cost is low, then low tool cost, and the finished parts are not always uniform. Close tolerance cannot be maintained. The spinning methods depends upon the extends on the operator skills, the product application, spinnings or the funnels, and or processing the kettles, racket, motor cases, and reflectors, kitchenware, and bells on the musical instruments, etc. The comparison of spinning and drawing. Spinning is comparable to drawing of making the cylindrical parts, and because of the simple tools used in spinning, it is economical for small lots, but the time required for making the cup is more spinning, and also more skill is required of in process, but thus it is not suitable for large scale productions. Complicated shapes and re-entrant shapes are not feasible by drawing, but can be made by spinning using the sectional and collapsible form of the blocks. Large parts are much more easily made in spinning than by drawing. Um, when the sheet thickness is more, for example, in making the dished pressure vessel, cold spinning is not sufficient, then the blank is heated for forging temperature of the and so process is called hot spinning. Also, hot spinning tools are mechanically manufactured because the high magnetic forces are required. Thank you. We will see you next video.